So my name is Neville.
And I'm Sergey. Good morning, everybody.
I want to start by welcoming all of you here. I want to appreciate you guys coming to this talk. This talk is going to be about 60 minutes. We're going to try and end it at 45 and give you enough time to ask questions about anything that we speak about today and any other questions you might have about our experiences on empowering DevOps with Cloud Foundry. By now, you should know we are from Comcast. If you don't, now you do. And when people usually hear that we are from Comcast, they usually have two questions. The first one, and the most obvious one, is, can you reduce my bill? No, I cannot, at least for me. Sergey, do you have any tricks up your sleeve?
No, sorry.
Okay, so we don't. The second question, however, hits home. And it usually goes along the lines of this. What are we doing to transform the Comcast customer experience? And the answer to that question is absolutely a lot. We're constantly working to change and transform our experience and add new features and services to the Comcast customer experience. We have a great bunch of vibrant developers who are constantly working to improve that experience. They, along with Pivotal Cloud Foundry, are at the heart of the Comcast customer experience transformation. Now, just like any other company, Comcast has monolithic applications. In the era that they were written in, sure, they probably served a purpose, and they served it well. But in today's world, where everybody needs things as fast as they can tweet, it's impractical. And it's very crucial for our company that our developers adapt and be more agile in this new era. Let's take a real-world example. The Olympics is just around the corner. We have to build apps that can run on so many different platforms, handhelds, desktops, and even on television sets. And the most important thing to note here is it is very impossible to predict the demand. People might just tune in to see Michael Phelps or Usain Bolt break their own records. And when that happens, it is important that your application is able to meet that demand and do it without disrupting the customer experience. Let's take an even simpler example. Some of you might have done this last night. You wake up in the middle of the night thinking, I've got this great idea for an application, and I want to start writing about it now. To match your enthusiasm, we need to have a platform that can take your dream from ideation to realization as quickly as possible. Because, look to your left, look to your right, one of the other developers woke up with a similar idea as yours. And as we know in the app world, there are a lot more stories about early birds that get the worm and second mice that get the cheese. So you have this great idea now, and you decide, to walk into your office. You can actually smell the big bucks for your next big app. And you see a chair that looks like Sergey's chair when he comes back from a vacation. Now, hopefully, somebody labeled it. Somebody gave you an instruction manual, and hopefully that instruction manual is well written. You have to put each of these nuts and bolts together before you can actually sit on it and do what you're born to do, which is develop. Now, your enthusiasm for writing the app is all shot, and all those big bucks that you were thinking about are starting to burn. Let's paint a different picture. You walk into your office, and you see a chair that looks like Sergey's chair before he went on vacation. All you need to do is sit on that chair and start developing. Sure, you need to know how to adjust the height, the inclination, and the feature I love the most, which is the lumbar support. But compared to what you have before, it is so much easier. That chair is platform as a service for developers. Sergey, you've been with Comcast for a long time, and PaaS is relatively new to Comcast as well as developers. What were we doing before PaaS, and how did we get here?
Yes. I joined Comcast well over 10 years ago, and you joined shortly after, right?
Mm-hmm.
So I guess we can claim quarter century of work experience with Comcast together.
Sure.
Yeah, that's a long time, lot of time at the office. So when we joined our team, and it was a cheesy team, cheesiest for Comcast high-speed internet, was responsible for everything that is related for provisioning high-speed internet to Comcast customers. That means our duty included everything from application design and coding all the way to hosting, particularly manage contract with the hosting facilities, with the data centers, order equipment, rack and stack servers, load operating systems, attach storage, configure networking PID, application networking, load balancing, and everything. So all this tasks take a lot of our time to do. And our BU, so-called business as usual activities, took majority of our time, left very little to innovation. That model has three major problems. One is a team capacity for innovate, that what I was just saying is very limited. We spend total less than 20% of the time for development and research and development. Time to market was quite high, because even just to start developing on new idea, we needed to create a development integration environments, all the things that took weeks and weeks and weeks to implement. And the last but not least, the problem with data center capacities. Because every deployment to production took at least 6 weeks, but most commonly around 2 months end to end, from purchasing equipment to put equipment to production. What it means then that we needed to plan capacity so well in advance, which is not always possible, right? So Neville gave example with Olympics, and some event might happen, and demand might grow very quickly. So we actually needed to over-allocate our infrastructure to cover events that might happen or might not. At the end, we ended up with underutilized equipment in the data centers. And also, by that time, Comcast started to add. We tried to optimize this. We started to use virtualization and containerization in low environments, and that was well before Docker existed. It was some success, so we had some improvements, but those improvements were marginal.
So to put this into context, the dream that you had is not going to be implemented. It takes at least 4 to 6 months to actually set up the infrastructure for your test and dev environments. Now, if you wanted to scale, that's an additional 2 to 4 weeks of making sure you have the right equipment to support your demand. The only good thing that came out of that, Sergey started to look like a bodybuilder carrying all those servers, right? But luckily, virtualization came along.
Yes, so once virtualization matured, and we were very lucky because at that time, Comcast started to add more and more services. So we added voice over IP, Comcast phone service. Set-top boxes improved with the power and new features, so DVRs become standard. Video on demand was become very popular. All that things that comes to customers require applications on the back end. So our portfolio of applications starts to grow very rapidly, and that means that with the way how we worked before, we need to build a new data center literally every 6 months. So virtualization reached maturity level to come to production, and we start massively virtualize all our, at least compute and storage resources in the data centers. And that was a huge help to improve resource utilization data centers, improve density and capacity of our data centers. But also virtualization gives us a way to put a service layer on top of it. And with that service layer, we were able to provide a self-service capabilities to our development and operation teams. So now our development and operation teams are able to build a new VMs and attach storage in minutes, not weeks and weeks and weeks as it used to be before. That was a major breakthrough in a time-to-market delivery for the applications. So we abstracted all the physical layer and all the way to operating system and from development and operations teams, and that squeezed time for deployments from ideation to realization by at least 6 weeks.
Yeah, so what you're saying, Sergey, is that, so initially we spoke about having 4 to 6 weeks to just set up the environment for your testing and development. That 6 weeks is now out of the picture. All you need to do is go to a website and say, I want a virtual machine with this operating system for your test and dev environments, and you get it right away, 10 to 15 minutes. Guess if you had to scale, you just do that some more. And now you have removed that 4 to 6 weeks out of your system, and you can just go ahead and develop. Scaling it is also the same. It becomes very simple, 15 to 20 minutes. But you still have to manage the operating system and the associated Puppet configurations that you have to do to your runtime environments to make sure that they can support your application. But we wanted more.
Yes. So when we started to feel what can be done with a proper API level for self-provisioning, we started to try to self-provision more things. And right, so Neville, you mentioned Puppet. That was, we were doing, once we moved to virtualization and start to more horizontally scale our applications on the existing infrastructure, our development and operations team starts to more and more invest into automation. And we used very actively Puppet, we use YAM repository for binaries, we use Artifactory Nexus for Java artifacts, and try to combine everything together with some automation tools, which takes some time to develop and maintain with the new versions of application, with the application lifecycle. If anybody in the room tried to automate like massive WebLogic deployment with Puppet and custom configuration, you know what I mean. So we wanted to bring that level of managed services as far as possible up. Particularly remove need for development and operations team to maintain operating systems, for example, to maintain application networking like a load balancing, SSL offloading, to maintain even application runtime. If it's Java application, it's Java. If it's Python, you need a different runtime environment. But that all evaluation happened at the time when we were also looking on the way how we develop application and our application lifecycle management. On the keynotes, they were said a lot about Devops and about microservices. And we felt that this is the way to go. But it's easier to say than done. Migration to DevOps from traditional way how large organization used to manage application lifecycle is not an easy task. It requires not just organizational changes, it requires cultural change. It also put quite a lot of load on on the infrastructure support, because to really enable DevOps, to really have DevOps working, DevOps teams needs to be able to do everything that they need without tickets that are executed in 2 weeks. So imagine you have your current Spring, you have your user story, but you need to put a ticket, and 2 weeks later, your ticket is fulfilled. But by that time, you have another Spring, you have another user story to deliver. So this kind of roadblocks needs to be removed. And platform as a service is really a true way to remove these roadblocks. So we evaluated different options and pick up Pivotal Cloud Foundry as our platform as a service solution.
So essentially, all you have to do is just write your code and trust us that we will run it in the platform without any issues. I know we spoke a lot, Sergey, and we're starting to sound like a whole bunch of salespeople, right?
Yeah.
So I think it's about time you actually show how easy it might be to just deploy applications using Cloud Foundry.
Well, yeah, at this point I was planning to get my polo off and expose a geeky t-shirt, but I realized that I won't have a clean geeky t-shirt until tomorrow happy hours, right? We have that tickets.
I won't recommend doing that either way, but go ahead.
Okay, so some demo for you. This is probably not everybody has a first-hand experience with the Cloud Foundry, so we decided to create a very original application that counts number of visits to the application. And this is a Spring Boot application, and it is using JPA for storing visit counter. So let's walk through the process of deploying that application to production and do something helpful with that. Spring Boot application built into a single jar file. So now I can deploy it. To deploy, what I need to do is to push it to Cloud Foundry. And all I need to do is a single one-liner cf push command with give it application name and location of the artifact. Cloud Foundry is not just for Spring, not just for Java. Despite of everything you hear on keynotes, Cloud Foundry supports many different applications, many different platforms and frameworks. If you have Ruby application, you do exactly the same. Push your code, and Cloud Foundry will figure out what to do. If you have, I don't know, Node.js or Python or anything else, you can throw it to Cloud Foundry, and there is a good chance that Cloud Foundry will host it for you. So Cloud Foundry combines your application, your code, analyze it, find what it needed, and for example, if it's Java application, it brings Java runtime. It might do configuration as needed. Create a droplet that contains everything that needs to run that application, including runtime and your actual code, and run that droplet on one of the VMs. So as you see, Cloud Foundry do it all in just seconds, and return back a URL that looks like this highlighted. By default, in this case, it's my application name dot some default domain. So let's now type that URL in a browser. It's a long one. It takes a little bit to type. And here it is, counter. That's the first visit to the application. I'm refreshing, and number of visits increase. Amazing, right? I can even type it as HTTPS, and you see this nice green padlock. So Cloud Foundry not just hosted my application, but also taking care of a DNS. It doesn't give me some IP address and long port number. It gives me a nice FQDN type. And also it do SSL support, so I don't need to do anything with the application. I don't need to issue a certificate and install it somewhere. It's all given. Right, also, as you can see at the bottom, this application just displays what data store it is using for persistency to keep that counter. And because we didn't do anything, it just decided to use in-memory H2 database. So JPA can work with many different backend solutions, as you know. So okay, let's move this. This application seems to be ready for production, but in production we never run anything as a single instance because things happen and we don't want to have any interruption to customer traffic if something is happening with that only instance that is running on some VM. So we need to add at least one more instance of the application and put a load balancer on top of it. And Cloud Foundry can do it. We can scale our application. In this case, we just need 2 instances. We don't have many hits. We don't have too much traffic. So performance is not a problem. But we can scale an application with 2 instances. Cloud Foundry will take that droplet. We'll find another VM to execute it. We'll bring droplet to the VM and run it, and put a load balancer on top of it to load balance between 2 instances of the application. Okay. Yes?
Is that load balancer that was created the same DNS name that
It will be the same DNS will be used for accessing an application. So this scaling happened without any interruptions. Users can continue to come and go. Yeah, okay, to your question. Now I'm just refreshing the browser, and you see counter continue to increase. Same URL, HTTPS, no changes. What happened? The counter is reset. Now jump back to 12. All right. I'll try not to panic. There are 2 instances, right? And they're load balanced. And that effect of jumping counters we've seen because load is now balanced between 2 instances. The backend it has been used for storing that counter is in-memory H2 database. So each instance actually has its own counter. That's not what we want, right, Neville?
Yeah, and the idea is we are not doing anything to the background, like do the load balancing. It comes standard within Cloud Foundry. Cloud Foundry understands there are a couple of instances and where exactly they are located. So when traffic comes in, the routers are aware of where all the instances of that application is and just passes traffic along. So we are not doing literally like exactly, this is the steps you would do, CF push, CF scale.
Yeah. Okay. So that in-memory solution does not work very well when we need to run multiple instances. And also, we need to persist this data to make sure that if application is restarted or we have a new version to push with the new features, then that counter should persist. So we need to replace the backend database for JPA. Cloud Foundry has a marketplace. Marketplace is the way to extend functionality of the platform with different type of backend systems. Backend systems might be not just databases. It may be a messaging solution, maybe an object store, maybe a centralized logging, or application performance management system. So let's see how it works. Spring JPA supports MySQL. So let's check if MySQL is supported by Cloud Foundry by the marketplace. So all I need to do is to type CF marketplace to see a list of supported backends, and I grab for MySQL. It's there. Now I need to create my own MySQL server for the application. Since it's supported by Cloud Foundry, this task is super easy. Again, one-liner. CF create service, give it a service type, and the service name that I want to use, in this case, S1P-DB, and associate or bind that service to my application, so the application knows where to find the database. CF bind service command, give it application name, and give it the service that I want to associate with the application. That's it. These two commands are enough to get a brand new database and have application know where to find the database. IP address, port number, username, password, database name, all is given by the application just with single CF bind service command. So application is started. You see 2 instances are running, still same two instances, but they were rebooted. I'm refreshing. You see at the bottom, now the URL is different. The database URL now is referring to MySQL. There are no any other tricks, no modifications of a property files, nothing. It's just CF create service to get a new database, and CF bind service to let application know where to push the data. Refreshing the page, counter increase, everything is great.
Yeah, you don't have to panic anymore.
No panic anymore. Production-ready application. So what if traffic starts to increase and we have more and more and more visitors to the application? We need to scale. And Cloud Foundry provides an easy way to scale an application. You already saw it when I ran CF scale with 2 instances just for redundancy. But we can scale much wider than 2 instances. So let's do 20. Give application name, say I want to have 20 instances. Again, Cloud Foundry takes that droplet, find 18 additional servers to host it, put the droplet on that instances, on that VMs, and boot and start that VMs. So just in a few seconds, you see, well, 19 of that 18 started, 1 is still in the starting phase, but 5 seconds later, you have all of them up and running. And now, if you go back to browser and start to refresh this page, this load will be spread across 20 instances. In our real production applications, we have much wider scale because we have a lot of traffic from millions. I forgot what is the number of, for example, set-top boxes that we have. Greg mentioned it on a keynote.
17 million.
Yes, right. So we need to scale our applications very wide. Some of our services running in hundreds of instances, for example. And Cloud Foundry is doing it pretty well. So it really can scale wide. In this example, I showed how can I scale manually my application in a few seconds. It's pretty cool, but what if something happened when I'm not in front of the console and event happened that requires much higher scale, much higher load? Cloud Foundry in the marketplace has an autoscaler capabilities. So you can define how you want to auto-scale your application, and new instances will be brought up when needed and removed when not needed. You can even create your own auto-scaling mechanisms if you want, and use Cloud Foundry API, which is very clean and very easy to use, to create whatever algorithm you want to use for auto-scaling. Just a quick recap. What we showed in this short demo is how to deploy an application with CF push command, how to create a MySQL database as a backend with a create service and bind service commands, and how to scale application.
Yeah, I mean, these one-liners are like so simple, like even Greg could do it. So moving on. So I know we have had this discussion. It's okay to go Pokemon hunting, but you cannot put your personal pictures up here. What's going on?
Well, Pokemon is a hot thing, and this picture I was taking just in one of the roads near my house last week, and I thought it's good to share because it's very relevant to what we are doing. It's a road sign saying, Pokemon free road, please just drive. Well, this is essentially what Cloud Foundry is doing for us. It takes all the Pokemons out of our road and let us doing our main thing. What we are intended to do is to develop and deliver new services to our customers.
So if I understand you correctly, what you're saying is everybody sitting here, we're doing things inefficiently before PaaS came along?
Well, let's see how our backlog looked some time ago. We had a long list in the backlog with the user stories like order new servers, configure storage, make a load balancer change for new servers that I deployed, patch operating system. And somewhere in the bottom of the backlog was, write some code and do some testing. What Cloud Foundry essentially helped us with is to get all that unnecessary user stories out of our backlog. So we can focus on writing code, on testing and deploying, rather than managing infrastructure. Cloud Foundry gives us API and command line interface that we can interfere, that we can work with to perform not just basic infrastructure tasks as we did with the infrastructure as a service, but much, much beyond that. Like automated scaling, zero downtime deployment, supports many different frameworks and languages, supports isolation between applications. So all that great features now available for us with just a single one-liner commands. And we can focus, we can clean our backlog of all those Pokemons.
And our developers love it. You know, we've been using this environment for about a couple of years. And just so you guys don't think we are just pulling this out of a hat, we've got some stats to actually prove it. The platform that we have at Comcast is about 18 to 24 months old. We have 9 pivotal Cloud Foundry deployments, each of them separate, independent of each other, and geographically dispersed across public and private clouds. We have a fantastic base of about 900 plus developers who are actively working with this platform every day. And usually when you have that many developers, you're going to see a lot of apps and app instances. We take a huge amount of traffic into the environment today, most of which are in the critical path of our customer experience. I remember the day when we started installing our first deployment. We were targeting a few teams to come in and try out the product, see how it increases their velocity. But we weren't anticipating this kind of exponential growth in the last couple of years. I remember last week, we were crunching some numbers about where we would be at the end of 2018, and we are projected to be close to about 30,000 application instances in our platform at the end of 2018. One additional thing to note here is that the Cloud Foundry platform is managed by a very few handful of people when compared to like infrastructure as a service where you needed to have a lot more people looking and managing the environment. The question is, why is it so easy? Why is there so much interest from the developers on this platform? It's all because of those one-liners. You saw Sergey mention them. If you have an app to push, you just do cf push my best done app, right? If you want to scale your app, sure, cf scale my best done app. What if you wanted to add your best done database to your best done app? Sure, all you need to do is cf create service and bind service, your best done app to your best done database. Now this is all very interesting, but it brings about a unique situation. And once people start sitting on this chair and doing all these one-liners, now all they need is they start dreaming about how can we make all these other things that we're doing outside of the Cloud Foundry platform into one-liners. What if I wanted an application to talk to a messaging system that is outside as a third party? What if I could scale my applications across multiple data centers, not just a single deployment, across multiple data centers, and load balance my traffic across different deployments? To do this today, they might be doing it outside the environment, putting in a ticket to a different team, handoffs. It takes a lot of time. So what if we had a one-liner from Cloud Foundry to just do that same thing, what took 5 days previously to about like 5 minutes? You start thinking about push-buttoning everything. You start dreaming a lot, and our developers are no different. Sergey.
Yeah, they're not. They're definitely not. They got the power, and power corrupts.
Yeah.
Yes. The most frequent once we have that developer base who started to do more and more on Cloud Foundry, these are the most requested features that everybody wanted. The first one is BYOU. Who knows what it is? Well,
the guys in the front row cannot answer. We've been rehearsing with them. So,
you are ruining these things. So who but Tim and Chris knows what it is? This is bring your own URL. The other feature is GSLB, Global Server Load Balancing. And when developers start to dig into marketplace, they want more services in the marketplace.
So Sergey, before you get into describing each of these, I want to play the role of a developer. I have this great app that I built, and I pushed it out. Everything looks great. It took like less than a minute to get everything deployed. But I got this www.myapp and this very long domain. And you typed one of them before in your demo.
Yeah.
Is there any way we can shorten it?
Yeah, that one from the demo, and it took some time to type on a browser, and it even longer to type on a handheld with the fat fingers, almost impossible. So we definitely don't want to present this kind of long URLs to our customers. We need to shorten them. And user friendliness is not the only reason for custom URLs. Cross-origin resource sharing or cookie sharing between multiple applications is important for developing secure micro applications that supports microservices and has multiple components. So we decided to implement it, and that's the path we took. So we created a registry that has a clean API for Devops teams to configure the services with URL translation that they need and with custom SSL certificates if needed. Data from the registry is used to automatically immediately generate adjust configuration files on the proxy tier that we have in front of Cloud Foundry. So that proxy tier is doing first level of load balancing between routers as well as SSL offloading. So now when users type a short URL, that hits the proxy tier. The proxy tier translated to Cloud Foundry friendly URLs, and everything works as we want.
So you just gave me a one-liner from Cloud Foundry to convert that big, long URL into a very short URL. So this one is usually accomplished by working with other teams and handoffs. So great, now I have a small URL, but my app is a hit. And everybody across the world is starting to consume all this app. They're starting to have complaints about latency. I feel like we should have my app deployed across multiple data centers. And I spoke to one of the networking load balancing guys, and they said it's about 2 weeks. Is there any way we can reduce that?
Yeah, this is JSLB. So we have many data centers in Comcast, and we load balance our application traffic between data centers. The way how we used to do before is a centralized team was managing JSLB appliances, and we needed to put a ticket to the queue to configure that appliances to perform very specific JSLB load distribution. And JSLB is needed for at least two major reasons. So you mentioned one. The second one is bring content close to the users to improve end user experience. But also it is absolutely critical to bring application reliability up and have multi-data center redundancy for the application. So we don't want to do the old ticket-based way to configure JSLB for Cloud Foundry-based applications. So we're starting to bring that functionality into Cloud Foundry, to extend Cloud Foundry functionality with JSLB features. So we are adding ability to for Devops teams to add a list of environments where the application runs into the registry, as well as load balancing method that they want to use, and health checks that JSLB service can use to determine if the application is up and running in a specific data center. So for the first cut of our service, we decided to use Amazon Route 53 as the driver, as the service, as a JSLB service for this auto configuration. And registry generates Route 53 configuration, Route 53 doing health check against all the instances of the application in different data centers. And now when users access the application, Route 53 directs them to the most appropriate instance that is up and running, well performed, and located close to them.
Yeah. So to put this in context, not only do you have a small URL in about less than 5 minutes, you can also use this API as a developer to put up all this information and load balance it across different data centers. So people who are close to Las Vegas can get their traffic served from which country, Sergey?
West Coast US.
Okay. It looks like you have some geography lessons in you, right? So let's see. I mean, what if I was in Brussels? Where do I get served from?
I heard the keynotes. It's somewhere in Belgium, so we'll have service in Belgium.
How about the city of Baku? I'm sure you don't know that.
Azerbaijan.
Oh man, you definitely passed your geography. But guess what? The auditing team came and told me they need logs. And they need all these application metrics to find out where our traffic is coming from. A lot of other services. Can you help me with some of that one-liners too?
Well, that's where Marketplace is helping us, right? So Marketplace has a number of services, and Pivotal provided several that are very convenient for us. And you want more. So
Of course, our developers want more.
that services are very, very convenient for much quick access by developers to backend services. But let me bring one more benefit of it, and I think this is very important. Things like a marketplace and Cloud Foundry actually promote innovation. Just a little story. We used to use relational database for pretty much every type of our backend storage. One of the major database providers, we rely on it. So we were storing not just relational database there, not just relational data there, but things like objects. So we used relational database for object store. We store some XML documents. We even store logs in database. We use database as a persistent solution for messaging bus. That was working for a time being because first of all, it's convenient. We don't need to learn new technologies often, and we have 1-800 number to call. But when we started to scale, we hit that wall, and we really need to introduce more and more effective and more targeted technologies for our applications, especially microservices. So we need effective messaging solutions, we need effective document store, we need effective object store, and everything else. It's hard for a developer to start learning by deploying how to deploy, for example, RabbitMQ or MongoDB or something else. Cloud Foundry Marketplace provides a very easy way with a single line to deploy many different technologies. So now, with these technologies available for developers, they can really innovate rather than learn how to install and maintain servers. So services that are requested, all kinds of databases, relational, non-SQL databases, object stores. They wanted logging, centralized logging. They wanted proxy services to enhance security of our application and being able to secure access third parties. They want application metrics. And when we start to think how to implement, how to extend Marketplace with all these services, we needed to pick up some common solution that will work for majority of them. And that common solution is, well, Docker. Because you can type Docker run RabbitMQ, and you will have RabbitMQ server. You can type Docker run MongoDB, and you will have MongoDB. You can type Docker run something else, and the chance is that something else will pop up. So we built a pool of VMs to support that are capable to support Docker containers, and we created a Cloud Foundry focused API layer to manage that Docker containers. Once we did it, we were able to quickly plug multiple services to this model and extend the marketplace. Okay, Neville, before you ask more, we also developed some additional tools for developers. They used to be able to SSH to VMs and say do connectivity tests, run a netcat or telnet command, or do traceroute to see latency to a database, or do PS commands to see performance of memory and CPU utilization required by the application. With Cloud Foundry, when you scale your application wide, it becomes not practical to SSH on hundreds of devices. So we developed tools that help developers to execute those tasks without need to SSH, but all through Cloud Foundry interfaces. And also one of the other very important extensions is extension to Cloud Foundry command line interface. Nick Bingham created it. He is not in here right now, but he will give a talk tomorrow about transformation that I believe at 5:40. So yes, this set of tools was created.
Okay, wow, all those great services. So the services that we just spoke about and the tools that we spoke about are currently being utilized or are in the phase of planning for our developers to use. And they're really happy with those one-liners that makes their life so much easy when compared to like what they were doing previously. Brings also a big question about visibility. You have all these apps and you're exposing all these APMs to your applications. But we had problems of exposing our platform metrics to our developers when we started initially working with Cloud Foundry. We have worked really hard on that over the last couple of years. And today, we are really comfortable with the environment. And we want our developers to feel the same way. As comfortable as we are with the environment and they're working with the environment, Platform as a Service creates a big abstraction. They don't need to know about the hardware. They don't need to know about the hypervisor, the operating system. All they need to know is that their application is running and running well. But let's all face it, at some point in our life, we all hugged hardware, right? We all like to get that hot air on our faces, as if we were in a commercial. But now that you don't have that, it is our duty to expose as many metrics as possible about the platform. And this is how we have done it at Comcast. We have a lot of different sources that provide vital metrics about the platform. We have Pivotal Ops metrics, we have Telegraph, we have the fire hose, we have our own custom scripts that we have generated. Now, all this vital data goes into the heart of our monitoring system, which is Influx database. We visualize the data in the Influx database using Grafana, so people can have a point in time or even a historical view of how the platform was performing. We use Capacitor to do anomaly detection and send those alerts and notifications into Slack channels. We are big users of Slack, which is kind of like the non-traditional tool, I would say, because everything is API accessible, it's easily consumable. The alerts and notifications that go into the Slack channel, developers can subscribe to that or integrate that with their own tools. We have our own Slack channel where our developers and we communicate very much. It's about 400 members strong, and it has organically grown over the period of time. It is at a point that today, as we stand here, we are part of the handful of people that manage the Cloud Foundry environment, so we are 2 people short of managing that environment. But they are there in that Slack channel answering questions to people who are coming in new into the environment and have questions about it. I think this visibility and the amount of information that we publish out about the environment is an integral part of our success. I think I hear some stomachs growling, so we're going to round this off with an overview of what we did today. We spoke about PaaS, that great-looking chair you have to sit and develop. Don't worry about the hardware. Don't worry about the operating system, hypervisor. Don't worry about all of that. Just do what you are doing and what you love to do, which is develop. Spoke about how it enables DevOps. Developers and operators, now that they don't have to worry about the nuts and bolts of that chair, can concentrate on making applications faster, delivering more services, and increasing their velocity. Spoke briefly about running Cloud Foundry at Comcast. A few keys to our success: listen to our customers, provide new services and tools that extend the functionality of the already rich Cloud Foundry environment, and visibility. It's very important to make sure your developers are comfortable with that platform so that they can just innovate and not worry about the platform. With that, we have come to the end of this talk, and we will take questions if you have. Yes?
You guys
So I'll just repeat the question,
Okay.
right? What you mentioned was, if I understand it right, sure, your applications can scale, but how do you do performance testing? How do you go about testing your complete application across the multiple instances? Maybe I can start off and you can add on. So initially when we deployed Cloud Foundry, we were, hindsight 2020, right? So we put everything into one single environment or a couple of environments. So your production applications, your staging applications, performance applications, were all running together. And soon we found out that's not really nice. So the approach that we have taken is we have started to segregate, the different environments, production environments, and we have a dedicated performance environment. So application developers can deploy their applications into performance testing performance testing environments, and they can scale and they can generate that same amount of load. And what we do is we have the ability to view that data and talk to the developers and see how their response times are. And based on that, we might scale our routers. So what we ask them is, what kind of traffic are we going to look at? And once they have this in a development environment, all they have to do is just change their endpoints to deploy to production. And we would be able to take whatever their max amount of traffic is.
Can you use that data then to set your initial kind of ceiling maybe on the instances that are allowed to spawn up?
So is there a limit to the amount of instances that somebody can just spin up? There is a limit. So when we create organizations within Cloud Foundry, it's an organization. All of them are limited by quotas. So that is to make sure, and we have a shared environment, which means, if one person is not behaving properly, it's essentially going to affect everybody else. So there are certain components that we can limit, but some on the other services, we might not be able to. So we limit the amount of memory that a particular application can use. When you hit that limit, you can request for more quota, and we can manage and provide you that quota. But your favorite one, are you going to start talking about logs now?
No. I wanted to put a little different perspective on a scaling in a platform as a service, specifically. Traditionally, when we were building applications, we created a farm for an application, and we needed to know what is the top utilization on that farm will be, and allocate resources for that. If you are going to host in Cloud Foundry a single application, then you will have the same problem, because you will still need to provision your hardware for that single application top load. Platform as a service really shines when you have a mix of a differently behaved applications together, running on the same physical environment. So you can have very, very little extra over allocation to have in that environment, because all of your applications will not suddenly request much more resources. But one or two might at some point spike, right? And because that one or two just is not a 80% of your overall capacity, but a small percent of overall capacity. Even when they spike 2, 3, 5, 10 times, it won't bring environment overloaded. So when we have a real good mix of different behaved application in the Cloud Foundry, and we monitor overall performance and utilization of resources, we know how they grow, we have some kind of insurance against that very, very, very huge spikes. So this is just another aspect. When your environment is growing, you're concerned about things like, okay, we have more hits right now. We need to expand our environment right now. That concerns are not as strong anymore.
Yeah, and
Separate environments that we scale horizontally to the worst case scenario. And I'm thinking, based on what I'm hearing, it's kind of great people having that mindset. But responsibly, you still have kind of those domains that in certain instances, you guys still kind of
So for anything like that, you still have to kind of capacity plan, but we do not currently have standby, servers to meet that demand. What we try to do at least, is make sure we have great cadence to understand, what the application needs are and when production applications are going into that. Now, there might be a need to increase certain components within Cloud Foundry horizontally. So, for example, routers. We might have 10 today. Based on the load, we might need to expand that to 20. And that can be done dynamically, and it's a non-interruptive, non-service affecting kind of change. All you need is to check a box and say, just change it from 10 to 20, and just deploy it. And it's non-interrupting your traffic. Once the routers start coming in, they will take the additional load that comes into the environment.
Okay, there were some more questions? Yes, please.
So, beyond changes that you made, like you just mentioned, segregating your environment, production tests, and so on, what other failures or roadblocks did you run into that you could, tell somebody like me who's just starting down this road?
Okay. So the question is, apart from all the segregation of different environments, performance, production, what are the other pitfalls that people who are starting out newly in the Cloud Foundry environment can learn from what we have done? We have had a lot of pitfalls, I'll assure you that. At least for me, and Sergey, you can follow up, but we have seen a lot of different things. For us who are managing the platform, it's a new environment for everybody. It's a learning experience, for us as well as the developers who are new to the environment. I can give you specific examples. There are times when we have brought a complete environment down because we were thinking, I'll probably give you the example. On a day, we were trying to help our developers by putting in new build packs. And at the same time, we started to the developers started to deploy more applications on our virtual machines, or the DEAs as they call it, or Diego cells now. And the Diego cells started caching all the new build packs. We were thinking we were trying to help, except all the Diego cells hit 100% space fully. We thought it was going to be non-interruptive, and we brought the whole environment down, and we were trying to figure out what happened. And we solved the issue. It took some time. Luckily, we had deployments across different data centers, so people could just move their application traffic from one foundation to the other foundation. And we try to be very open about it. When things happen, we have a forum with our customers so that this is exactly what happened, this is what we did to resolve it, and here is what we're doing to prevent this from happening in the future. We were not monitoring the ephemeral disk space on the DEAs. All that becomes public. And we're not trying to hide anything. All that data that we spoke about is published and available. So I think that kind of openness and making sure that we listen to them, I think has helped absolutely, great, at least from the platform side. From the developer side, you might have insights.
Well, I don't know what to add because things do really happen, and the real path to success is be completely transparent both ways, always, and communicate with developers. We sit together with developers trying to troubleshoot issues that they have in Cloud Foundry, and while doing it, we're learning together with them. Cloud Foundry itself is a pretty redundant and resilient platform. Actually, just a day before we flew here, there was some problem in one of the applications, some very minor problem, some transactions failed. It happened to be a memory leak in the application. Not a big deal, it happened. But somehow it happened only on one environment and didn't happen on another environment where the same application was running. Well, when we start to dig deeper, actually application crashed before in the other environment as well, but because Cloud Foundry was able to recreate, reinstantiate all the instances, nobody even noticed. So that tells how good Cloud Foundry can manage different situations by itself. It's not, and also gives us a lesson that we really need to do more and more monitoring and visibility, because we frankly should know about that events that Cloud Foundry corrected.
So it's working just very closely with the developers, and you will find that they come from a traditional environment to a cloud environment, and things like logging, we have had so many issues with logging, and it's just talking to them and telling them, hey, this is not, Cloud Foundry treats logs as like really low level, so log only what you have to log. Don't put all those critical information that you need through your logs and collect them. So it's mostly been, a close partnership with the development teams that's helped us a lot.
Guys, do you think it's safe to say that the problems we've had are not necessarily with the platform or our own mistakes?
So the question is, do you think there are problems with the platform or, with mistakes that we make, along the process? I would say there have been issues on both sides, but mostly, it's just getting used to the new environment. It's the old way of doing things. We have done a lot of things the old way, and when you get into the cloud environment, some of them simply don't scale or simply don't or become irrelevant. So, we have had issues. Our developers, once they started utilizing and pushing apps in there, what we found is they made a complete switch from one running application version to another and caused an 8-minute outage on our billing systems because they did not account for all that traffic that simply cuts over, from one version to another version. And it was an eye-opener for them. And that was, I think, one of the plugins that Nick, who's going to be talking later on, I think tomorrow, he wrote a plugin that seamlessly takes one instance from the old version, moves it to the new version, makes sure, and does this in like a rotational way so that there's no downtime involved in that. So they have learned stories too, and we have learned stories that we haven't, done properly within the environment. We learn from that, and we start making changes.
Let me just add, so you essentially asked if Cloud Foundry is the absolutely perfect solution for everything. Well, maybe not. It has some problems that needs to be solved here and there. We are working closely with Pivotal and with Cloud Foundry Foundation to help with the request, with the backlog, what features are the most important to implement, what bugs we found while working on the platform. So every piece of software has a bugs, and we need to deal with that. So we just need to make sure that when we're developing and deploying our applications, we do it in the way that, well, let me put it this way. Any distributed application almost always works in a failure mode. When you have large distributed application, some piece at any point of time probably is failing. So you need to be able to develop application resilient enough to not bring down customer traffic when one piece is down or another piece is down.
So I know we just hit the 12:40 mark, and that's like 1:10 into our talk. I think it makes sense for us to leave the podium for whoever might be coming next. But we're going to be here in case you guys have more questions, and we'll be happy to answer them. Thanks again for being here. Appreciate all of you. Thank you.
Thank you.